Okay. Measure of central tendency. What is the measure of central tendency? Means measure of central tendency means data is scattered from where to where? From 10 to 60. Am I correct? How much data, where it is distributed? Which is the middle point? Central tendency means center. What is the center point of the data? We need to understand. But if I have taken mean means what is that? Average. Average. If I have taken average, will it be center point? Most of the time, but not every time. So that mean, median, mode, there are three things are there to capture the center point. This mean and median, mode, these three things we need to understand. Those are things called as a central tendency. What is the center point? How to take? Is the mean is perfect one, median is perfect for central tendency. Okay, let us go. Population, mean, median, mode. Okay, measure used to determine the central tendency distribution is a mean and median and mode. What is the mean? We can understand first, then we can go to median. Right. What is the mean? Mean is nothing but it is average. Everyone knows average principle for average. What is the average principle? Sum of all by number. Very good. So that is population mean. What is the population and what is the sample? Yesterday we discussed. Population is a whole group. Sample means a small group. That is always subset of the population. So as it is a whole group, we are saying that the population mean we are denoting with capital N. Population is denoting by capital N. As it is a sample is a subset, small n. Okay. These are very much important because in formulas, based on small n, capital N also more confusion will be there. Because in machine learning, for sure, there are n number of formulas will be there. Okay. But main thing, not by hearting, understanding. Right. Population mean capital N, or else we can say as a mu also. Mu. Mu is summation of I equal to 1 to n. I, this is I, it is not 1. Okay. I equal to 1 to n, xi by n. By this, what you understood? This is summation. Actually, people use it to call as a sigma. Of course, it may be the sigma later, but we have to call as a summation of I equals to 1 to n. Means n is number. I equal to from starting point to up to end. How many are there? If the 10 numbers are there, n equal to 10. 1 plus 2 plus 3 plus like that up to 10. N equal to 10. Xi. Summation of xi means all x's. All the numbers by n, by capital N. So a small example I have taken 1, 2, 3, 3, 4, 4, 5, 6. This is our population. Suppose, okay. Population n mean, population mean what is the principle? Summation of I equal to 1 to n, xi by n. Just totaling we are doing by 8. Okay. So how much it come? How much it came? 3.5. Okay. So this is the population mean. But what about sample mean? I have not taken here any sample, right? So X bar is called as a sample mean. Because all are x's we are seeing x1, xi means x1, x2, x3 like that xi. So sample mean is small n or else x bar we can say. Okay. X hat will be different. In future x hat will come. Okay. I'm not going to give confusion now itself. But x bar it is different. Summation of I equal to 1 to n, xi by small n, that's it. So a systematic sample I am going to collect from this. Systematic sampling. Can we say every third number is our sample? Every third number is our sample. So first number, which one comes? 3. 3 plus 4 and 4, this 4 plus 5. 3 plus 5, 8. Okay, here, right. Okay. Yeah, 3 plus 4 will come. 3 plus 4, 7. And 5, 6, we have to leave. Yeah, please. So only 3 and 5 will come. Every third number means, right? Am I correct? This is the first number, third is third number, and fourth, fifth we have to leave. Sixth number again we have to take. Sixth number is 4 only. 3 plus 4, it is 7. Fifth, sixth we have to leave because we have to take the ninth. But there is no 9. Only 8 numbers are there, right? So 3 plus 5, 3 plus 4. 3 plus 4 by how much? 2 only. 3 plus 5, 7. 3 plus 4, 7. 7 by 2, again it comes to 3.5. That is the inferential statistics. So, without doing the total population mean, by taking the systematic sampling, what is the sample mean here also? It is also 3.5. So that we need not to take the total population always. Only sample we have to collect. Whatever the sample mean came, that is only exactly coming to the population mean also. But in real time, what will happen? Little here and there will come. Because here only 8 numbers are there, exactly I have taken. Even if I have taken a random sampling, it may differ. Okay, it will differ, but we have taken systematic sampling like that. So this is the nothing but inferential statistics and sample mean. This mean is called one of the central tendency. So where it is there, 3.5 means it comes to 3 to 3.5, in between 3.4, 3 to 4, in between it comes to 3.4. Right? 3 to 4 in between it comes. What about median? Median is middle number. Median is middle number. So before middle number also here 3.5 it is coming. But in real time data, always median and mean will not be same most of the times. If it is a Gaussian distribution, it is forming. Now exactly mean and median will come equal. But most of the times it may not happen. Okay, right? Median is nothing but middle point. So this is the middle point. So how many numbers are there? 8 numbers are there. In 8 numbers, we have to make it as a arrange. We need to arrange either ascending order or descending order. Then only it is possible. Without doing that, mean can be taken. Mean can be taken, same thing will come, but median will not become. So I have arranged it right. What is those numbers? Please tell me by looking there.
1, 3, 3.
1 is there, right? 1, 2,
3,
3, and 3,
4,
4, 4,
5, 6.
5, and 6. 1, 2, 3, 4, 5, 6, 7, 8 numbers are there. Okay, it is an even number. If there are only 7 numbers, middle only one number will come. As it is an even number, 8, this 3 and 4 both comes. Again, mean of the 3 and 4, that is 3.5. Here, mean and median both came equally. So automatically, if you distribute the data, this curve will come. 1. 1 means here only it will be there, right? 1, 2, 3 means mean and median are equal. 3.5 means totally from here to here also same data, from here to here also same data is distributed. So that automatically that curve will come. But here, if you have taken the mean and median, will be different. Okay. We will take this exact examples. I don't want to make you confusion. Median is middle point, mean is average. Right. What about mode? When we have to go for mode? Mode is most occurring value. What is the mode here?
3 and 4.
3 and 4. There are 2 modes. But when to go for mode? What is the purpose of mode? Repeated. Why we are taking repetition means it is the purpose of not for numerical values, it is for categorical variables. Okay, categorical variables. Suppose I have taken the data from one survey group. In that survey, educational qualification is there. Okay, educational qualification is there. So just to see the example, educational qualifications are SSC, Inter, BA, BSc, BA, BA, SSC, BA, MBA. BA, how many times it is repeated? 4 times. So mode is BA. Mode is always, most of the times, for categorical only. So why this mean median mode is in our data science it is required? Means to fill the missing values. Okay, to fill the missing values. So all the columns are there, IDs are there, names are there. Okay, in my data, some people don't want to say their age. Some people they don't want to say their education qualification. Right? So some missing values will be there. If only one value, one missing value, the total record we need to remove. If you go by removing, what will happen? Data will be less. Our machine learning algorithms, accuracy will less. So something we have to fill only one column. You told everything regarding you, but age you did not told. That is not your interest, of course. What to do? Some age I have to fill. Which age I have to fill? Either mean or median. Either mean or median by filling our machine learning algorithm can be completed. Some people won't say their education qualification. At that time, what to do? We can't take the education qualification mean and median. There is no mean and median for education qualification, right? Then we have to go for mode. Number of people are done BA in that group. So he is also done his BA. We can fill it. But when again we have to go for mean, when median. So if the data is like this, we can go for mean. If not like that, skewed data, we have to go for median. Why mean, why not median? I will explain in future. Anyone coming or just closing?
Go and go.
Huh?
He just go and go.
Okay. He afraid by looking you. Okay. So we will discuss little later. Okay. When mean, when median. So this is the mean, median, mode all together called as a central tendency because all are in between. Central point only they are concentrating. Measure of dispersion, variance and standard deviation. What is the variance and standard deviation? Anyone having any idea? This is important one. You have to understand well. This is also called as a sigma, but variance is 1 by n summation of I equal to 1 to n xi minus mu whole square. You need to understand. Please concentrate more. This is the middle point. Middle point means we can say as average. We can call it as a mu. Is it fine? Everyone agreeing. This is mu because it is average. From here to, from middle point to how the data points are scattered. This is the variance. From here to here, how much distance it is there? Distance. Sorry, standard distribution. Standard distribution means how it is distributed. From here to here, how much distance it is there? Again from here to here, here, here. From middle point to every point, we need to take the distances. All together, we need to make a square root. So that what will happen? Finally, from any point, standard distribution I am saying, because from here to here distribution is different, from here to here distribution is different. But overall, every point from here to any point, if you take one standard distribution has to be there. Means in between any number, in between from here to here, here to here, any point to point, what is the standard distribution? Distributions are anyhow different. Exactly in equal point will not be there, right? But one standardized point I need. Standard distribution means in point to point, how much distance it is there. In two different, if I take these 2 points, different distance will come. From here to here, other distance will come. But what is standardization? What to take? So standardizing where? How to standardize those things? From middle point to every point we have to measure. Then we need to summation by how many points are there by n again. That is an under root. That is a standard distribution. What is a standard distribution? Did you understood or not? And variance is regarding the data, not these points, data points. So how much variance is there? What is the area? This area it is showing. So this is a square, just simply how to keep in mind. Okay, this is a square, right? This is A. This is also A. What is the area? Area. A square, right? Side is A square is area. What about the length? A. So what is the variance and standard distribution? You have to keep in mind in this way. That's what actually. Okay. Variance is big one. Variance is this thing. How the data is distributed. Just now I have seen up to 8, up to 10, like that. All the histogram parts, if we mix it, it will come like this, right? Right? So this area is called as a variance. Variance is always, area has to come without squaring. Sorry, if we square, area will come. Right? Just see this. Variance is, oh, you are not able to see, right? Yes, okay. Okay. If the TV screen is there, that will be more good. This light is not. Variance equals to 1 by n, capital N, summation of I equal to 1 to n and xi minus mu. Xi minus mu whole square. Why whole square? Xi minus mu whole square we are taking. Because this is the mu. This is the mu. Middle point, it is mean and mu. Here to mu is a 4. Suppose 8. Mu is 8, suppose we can say. If it is 8 means from going to right side, more than 8 will come or less than 8? More than 8. For sure it is 9 and 10 and 11 like this. If you come to here, left side, what will come? 7, 6, 5. So, but we have to do what? Xi minus mu whole square. This is x1, this is x2, x3 like that, right? Xi means that is only I equal to 1 to n, all the thing. So 5 minus 8, what will happen? 5 minus 8, what will happen? Minus 3. So if it is minus 3, again what will happen here? 5 minus 8 here and 11 minus 8. 11 minus 8 what is? Plus 3. Plus 3 minus 3 will be cancelled. Finally nothing will be there. So how to calculate? For that purpose actually then and there they have done squaring. So that 3 into 3 9, here also plus 9, here also plus 9. Otherwise everything will be 0. So that formulated like this. This is a standard deviation. Standard distribution. Okay. Standard distribution we can say standard deviation. Deviating from point to point. Standard deviation also we can say. Okay. Sorry, variance. This again and again we will get confused. Variance. Okay. After that, so that actually by squaring what it is coming? This area is coming variance. But if you square root again, the same formula just to add square rooting. By square rooting, what will come? No square will be there. Just no square will be there. So that it will be squaring. Square root taking. So what happens? Only that distribution will come. At that time, area will come. We are squaring. Otherwise, without squaring, what will come? Only standard deviation will come, but variance has to come means we have to square. By squaring this area, this length to length, squaring means total area will come. That is called as variance. Are you understanding? Or am I confusing you? No confusion. Variance is area. Standard distribution deviation is same point. Why we are doing without? Why we are doing here the square means if we don't square, it will sum up will be the 0. For that purpose, we have taken so that what is happening only this lengths are not coming. Standard length is not coming. Square coming means this area will come. Okay. So after getting the area, what to do this standard deviation for the purpose? We have to root square. Square root we have to do. Right? So that this is square root. Only difference is square root. Standard deviation. Only distance between the points will come. I think I explained well. But if you not understood, also always welcome. No issue. Right? This is very important. So what is a low variability? Variance, low variance and high variance, how it comes? If the area of the curve, under the curve, if the area is less, that is low variance. Right? So low variance curve, how it is showing? Variance is low means this distance is low, but height is more. Total data is scattered in middle point only. So variance area is very less area. Low variability. But this is a blue line is a medium variability. This is less variable. High variability, sorry. Okay, this is medium variability. This is high variability. Variance means actually how it is distributing from which point to which point, how long from here to here data is scattered. But in low variability curve, only within the middle point only it is covering, right? So this is low variability, medium variability, high variability. Just now we have seen our frequency distribution. What type of data it is there? Very high variability. This height is very less, but here 8, 6 and 10, here to here, it is variance is high, right? Okay. Standard deviation. Standard deviation means a statistics better measure. It is standard deviation. Just now I explained. That is nothing but standard deviation. Okay. So if it is a mu equal to 0, here are -1, -2, -3, here 1, 2, 3. Means from here to here, if our mu equal to 0, then only what happens? Here minus, here plus. If our mu equal to 8, here 9, 10, 11, there 765 like that it will be there. Okay, dispersion of the data on the line. Okay, right. Standard deviation, variance, these are very much important. Mean equal to summation of x, summation of I equal to 1 to n, xi by n. It is very simple formula, no need to worry. But variance is, it is also simple, xi minus mu whole square will be there. Xi minus mu whole square. As it is a variance is sigma square, standard deviation is square root of it. Just square root of it. So that distance, side distance will come, it is area. Calculating the variance. Let us calculate. Sir, are you getting bored or what? You are getting some sleepy or drowsy? Huh? Okay. Oh, okay. Can I have your introduction, sir?
My name is Lakshman,
Okay.
Senior Project Manager.
Okay.
for two.
Okay. Want to know or want to learn?
Huh.
Want to learn. Great, sir.
Want to make a career.
Huh?
Want to make a career in AI.
Yeah. So now, as a project manager, why you are coming to this side, sir?
I want to like be in touch with the latest.
Latest subjects. Okay. Great, sir. I am also such type of person. After going to very high level position in IBM, I came out and I learned the data science at the time of Corona, immediately after Corona. Working for which company, sir? MNC. Yeah, any new guys came today? Yeah, please, sir. You also same, I think.
Yeah.
You
I
both are
came for
friends.
demo. I'm
Okay.
into testing actually.
You are in testing.
He's my cousin.
Okay, okay.
I also just want to learn like what is data science and
Okay.
future is AI.
Okay, okay. Great, great. Because anyhow, in another 10 years, we can stay on this subject. That's what actually I felt. So I moved. I was in SAP BW. That was from 3.0 B onwards, actually, I worked. Okay, 3.0 B, 3.1 C, suddenly 3.5, suddenly 7, finally, HANA came. Okay, total change. So, but again, another 10 to 15 years, we will be on data science. It is a long future it is having. Still, we can learn this thing. Okay. Any new persons? Yeah. What about you?
My name is Shyam Kumar, sir.
Okay. You can say that there is no issue.
It's okay, sir. Respect for that.
Okay, thanks.
So Shyam Kumar, sir, I completed NCA recently.
Okay.
I'm good at Python, so I want to learn data science with AI.
Okay.
My demo class, sir.
Yeah. Okay. You are good.
Myself, Ramesh, actually I'm working as a statistical programmer
Oh, great.
in technical domain.
Okay.
So I would like to change my career path from statistical to data science.
Anyone new? Yeah.
Myself says, like I am currently doing my Python intern, so I wanted to know.
Okay. Yeah, because yesterday and day before yesterday, 2 sessions are completed. Of course, those are also just demo sessions. But how the Python is easy to learn, and also what is the basic statistics also explained. Today, actually, just we entered into the standard deviation up to, but of course, it may not be immediately, you may not catch the points. If not, also, I'm going to take the backup classes for very new today. But of course, yesterday and day before yesterday, nothing has happened. Just yesterday, little bit we were in subject. So Python also I have shown little bit. And also Python installation I did not explain as of now. Tomorrow I am going to explain the Python installation. And also one more thing I want to explain. On Monday, there will be no class. I am going on my personal work. So tomorrow we can have session. If everyone ready with your laptop, tomorrow we can go ahead of installation of Python and Anaconda. So that from Tuesday onwards, we can go into the practicing sessions also. All are ready? Tomorrow, can we go for installation of Python? Okay, good. So that actually today itself I want to start, but management told today also maybe some new people may join. So that just I am continuing very basics of these things. So if I start the subject, I will go continuously little speed maybe. Okay. So today we have completed central tendency as well as this standard deviation and variance. Because one thing you can stop at any time, any point of time. Because in my understanding level, I used to go. You can stop at any time. Because learning the total subject is different, but learning perfectly is more important. Because as I am very well, I know very well this subject, I may think it is easy. I am telling simply. You are also understanding very easily. But if you are not able to understand, then and there you can stop. Because again and again we can learn. If you learn less also, it is okay, but we have to be perfect. In resumes, actually, I have to see everything they used to keep. SVM, I know, deep learning, I know, ANN, I know, everything, but some such type of very basic things also people won't explain. So that's what actually on basics also I'm concentrating more. As of now, it is okay up to standard deviation and variance. You understood well, I think. But still, if you feel difficulty, please let me know. Because up to central tendency, it is okay, good. But it is people feel difficulty little. What about you? Is it fine? Okay, good. Then we can go ahead. And regarding Monday also I told, but in Saturday, anyone having any personal works also, please stop for me because you have to attend the tomorrow session. On Monday, anyhow, I am going to take a leave. Okay, these are my personal work. Okay. Can you go ahead of class tomorrow? Everyone is ready to come. Yeah, because from next month onwards, because tomorrow is second Saturday. Every Saturday, second Saturday, we can take a holiday. Second Saturday and Sunday as a state government holiday. Okay. Other than every Saturday, we can have a session because we have to complete in 4 months. I plan to teach a lot of subjects. That's what actually. But of course, in middle, if the subject is not required, such type of things are there. We can keep it aside, no issue. But important things we have to learn perfectly. Okay. How much subject we know is different. How much depth we have is different. Because mostly we have to concentrate on ANN and PNN, such type of things, and SVM. Again and again seeing this statistics also. Yeah, one statistics guy is there. Is it fine? SAS, SAS. Yeah. Okay. So statistical analysis, anyhow, you know very well. Okay. Now, is the speed is good for everyone? What do you think?
I think they need some more clarity.
Okay.
How the data will come and how the data they have to get everything. We can elaborate the something so that we can people understand.
Okay. Yeah. Yesterday also I have taken on statistics only. Yesterday those things I have completed.
But I think they don't have the knowledge of statistics.
Statistics.
Standard deviation and everything.
Okay. No, yesterday even frequency distribution also I have done just now. Okay, today itself, even yesterday sampling techniques, population and sample, all those things we have completed.
As you said that how, in which situation you have to take the sample, and which situation you have to take the sample.
Okay, yeah, those things at the time of real time in the projects only I am going to explain. If I say everything now itself, it will be more confusing. Anyhow, sample is different, population is different.
But these people don't understand, right?
Okay.
So that's why I'm saying.
Okay, it's okay. I'll try to explain. Yeah, calculation of variance, at least we can complete today itself. Okay. So I have taken very small values. Otherwise, we won't get understood. Anyhow, with the help of Python, huge data also we can take variance and standard distribution. But here, for example purpose, just small things I have taken. It is 1, 2, 2, 3, 4, 5. These are the values. Are you able to see here? 1, 2, 2, 3, 4, 5. It is as it is yellow color, it is not able to. Okay. to change those things. That is better. Okay. So mu equal to 2.83. How it came? Mu is very simple calculation. 17 by 6. Total is 17. How many values are there? 6 values are there. Okay. It is a mu population mean. So mu minus xi minus mu we have to do, right? Xi minus mu means what is the first one? 1. 1 minus 2.83. How much it will come? 1 minus 2.83 minus 2 minus 1.83. Like that in the all those things. 0.83 minus 0.83 minus, these are minus. Okay, then 0.17, 1.17, 2.17. Okay, so if we add almost, it will come to 0. That's what we are not doing directly, we are not adding. Summation we have to do, right? But before summation, what we are doing? Whole square we are doing. So that 3.34, 0.6889, these values will come. Okay. Now squaring equal to summation we have to do. Summation is 10.84. It is coming by 6. This is 1.81. What is this? It is a variance. With square it is coming means it is variance. 1.81, it is a variance. Just square root of variance is standard deviation. Standard deviation, standard distribution we can call. So square root of 1.81 equal to 1.34. This is the standard distribution. This is the variance. So standard distribution and variance. Variance is the area. Standard distribution is the in between the length. As it is a length, no square will. That's it.